So yeah, we have the ratio of the linear expansivity of copper to that of iron is approximately 1.5. A specimen of iron and a specimen of copper expand by the same amount per unit rise in temperature. The ratio of their length is, so first we know that linear expansivity is change in length over original length per degree rise in temperature. So that means we can say linear expansivity of copper is Cu, is change in length of copper over original length of copper per degree rise in temperature, and linear expansivity of iron is Fe, is equals to change in length of iron over original length of iron per degree rise in temperature. So now, if you look at the question, the ratio of linear expansivity of copper and that of iron. So I'll put the two in ratio. That means alpha of Cu divided by alpha of Fe, that is linear expansivity of copper divided by linear expansivity of iron. So we have it here. So that means change in length of copper divided by original length of copper per degree rise in temperature divided by change in length of iron divided by length of iron per degree rise in temperature. So if we have this now, so continue with the question. So we have a specimen of iron and a specimen of copper expand by the same amount per unit rise in temperature. So now if they expand by the same amount, that means the change in length of copper will be the same thing as the change in length of iron. This change in length will be equal. Also the temperature will be equal. So but let's change division to multiplication. So now this is 1.5. The ratio of copper and iron, the linear expansivity is 1.5, is given in the question. So it's equals to change in length of copper divided by original length of copper per degree rise in temperature times, anytime division change to times, so this one will go up, this one will come down. So that will be original length of iron times the theta over change in length of iron. Now from this statement here, that the specimen of iron and specimen of copper expand by the same amount per unit rise in temperature, it means this change in length here, it will be equal to this, and your theta will also be equal. So now the ratio of their length is, so question is now asking for the ratio of their length. So we have 1.5. if you change it to fraction, remember I said if you want to change a decimal point to fraction, you remove the point. So this will be 15 divided by 10. So if you remove the points, is equals to, so you remove the points, you write 15. So divided by every number here will be 1, and each number after decimal is 0. So watch my video on how to change decimal point to fraction, so you understand that part. So we now have linear expansivity of iron divided by linear expansivity of copper. So that's what we have here. So and according to the question, so the ratio of the linear expansivity of copper to that of iron is approximately 1.5, which is copper to iron. So the ratio is copper to iron, and the length here is iron to copper, so I have to change the length to copper and iron. So since this is for copper, this is for iron, so we can also reduce this, like 5 here 3, 5 here 2. So now this is equals to Fe over, so it should be copper over iron. So you can take the reciprocal of both sides. If I say reciprocal, it means you turn this upside down, you turn this also upside down, or you cross multiply. But I'm taking the reciprocal of both sides. So if this is now 2 over 3, then this will be length of copper divided by length of iron. So that means this is the ratio of their lengths, so in terms of copper and iron. So that means this will becomes length of copper divided by length of iron. So 2 divided by 3 is 0.67. So that will be 0.67 answer. So that's the final answer. So normally if you leave it here, it will be 1.5, but that will be iron to copper. But in the question, we have the ratio of linear expansivity of copper to that of iron. So I have to make copper length of copper over length of iron. So that is 0.67.